Hello everyone, welcome to the week 12 problem solving session for the pattern recognition and application course. I am Tanuka from IISc. Today we will be talking about some more clustering algorithms and solve some problems using those clustering algorithms. So let us get started. So the first problem that we have is cluster the following points into 4 clusters using Batchelor and Wilkins algorithm, and the points are given. Okay. There might be a small delay in my connection in my presentation. I am having some small issues in the network connection, just excuse me for that. So the problem is you have to cluster the points. There are 8 points given into 4 clusters using Batchelor and Wilkins algorithm. Yeah. So the first step in solving this problem will be you can take any point as your first cluster center, or first cluster center. Any point you can choose. Let's say we choose the point A as our first cluster center. Then we will have to choose the next cluster center as that point which is furthest from A. So you will have to compute the distances between A and all other points, and you will have to take that point which is having the maximum distance. So these two will be your first 2 cluster centers. Now once you have 2 cluster centers, the other points you will have to assign to one of these 2 clusters depending on the distance. You have to see to which cluster center the distance is minimum. You will assign the point to that particular cluster. Now once you compute these minimum distances with the cluster centers, then if you need more than 2 clusters, you will have to choose the maximum of these minimum distances and take that point as your third cluster, and you have to go on like this. So the first step in the Batchelor and Wilkins algorithm is to obtain the weight matrix between all pairs of points. So these points that I have taken here is the same as the points used in last week's session, where we use this for agglomerative clustering. So I'll just write down the weight matrix that we already computed last week. So the weight matrix will be something like this. So weight I called it weight matrix, but it's actually the distance matrix I mean to say. So the distance between the point A and A is 0. Between A and B, the distance is 1. Between A and C, the distance is 3.6. Then 4.2, 5.9, 5.4, 5.7. With B, the distances are like this. So this is the distance matrix that we have, and let's say we take A as our first cluster center. A is our first cluster center. So now if you check the distances of all other points from A, then you will see that point E has the maximum distance with A, which is 5.9. So this is the furthest point from A. So we will choose the point E as our second cluster center. So E will be our second cluster center. Okay. Now the next step, this is the first step. Then the next step will be to compute the distance of each point, each of the other points except these two cluster centers, the distance of each of the other points from these two cluster centers. So you have two cluster centers A and E. You have to compute the distance of B, C, D, F and G from the points A and B. So you can easily get these distances from this weight matrix. So the distance of B from A is 1, C from A is 3.6, D from A is 4.2, F from A is 5.4 and G from A is 5.7. Now the distance of B from E is 5.5, C from E is 2.3, D from E is 2, F from E is 2.4 and G from E is 1.3. So these are the distances of B, C, D, F and G from the two cluster centers A and E. So you will have to now, for each point you will have to choose the minimum of these two distances. So for B, the distance with point A is 1, point E is 5.5. So the minimum is A. Now for C, similarly the minimum is 2.3, which is with E. For D, again it is the distance 2, which is with E. For F also it is minimum with E, G also it is minimum with E. So now you have two clusters. Now you have to choose the third cluster center. I still think there is a delay between the presentation and my current screen. I am unable to do anything about it. Let me reshare the screen. Yeah, I guess it's visible now. So now you have to choose the third cluster center. So that cluster center will be, you will have to choose that point which is having the maximum among these minimum distances. So if you just see the minimum distances, the ones circled in red, the maximum among them is 2.4. So the next cluster center that you will have is F. So F will be your third cluster center. Now you have three cluster centers A, E and F. Again you will have to check the distances of each point from these three cluster centers, and you will have to choose the minimum of these distances. So from the distance from A and E you already have, you will have to check the distance of B, C, D and G from F. So the distance of B from F is 4.6, C from F is 2.5, D from F is 1.5. F is already a cluster center, so no need to find its distance. G from F is 1.1. Now if you see, for point B, the minimum distance is still with A. For point C, it is still the minimum distance is with E. But for point D, the minimum distance is now 1.5, which is with F. So the minimum distance is not anymore with E. So I'll just cross it and put. For G also the minimum distance is with F, not with E anymore. So this is the new set of distances that you have. Now the question asked us to have 4 clusters. Currently we have 3 clusters. So we will have to again choose the point with the maximum distance among these minimum distances. So that is, you can see 2.3, which is the point C, and its distance with E is the maximum, which is 2.3. So the next point that you will choose is C. So these are the 4 cluster centers that you have for your 4 clusters A, E, F and C. Now the remaining points will be assigned to one of these clusters, that is based on the minimum distance criteria. So if I write it clearly once more, you have 4 cluster centers A, C, E and F, and other points are B, D and G. Distance of B from these points are 1, 3.2, 5.5 and 4.6. Distance of D are 4.2, 1, 2 and 1.5. Distance of G are 5.7, 2.2, 1.3 and 1.1. So if you choose the minimum distance, then B will be assigned to the same cluster as A, D will be assigned to the same cluster as C, and G will be assigned to the same cluster as F. So now you have 4 clusters. So A, B is in one cluster, C, D are in one cluster, E is alone, and F and G are in the 4th cluster. These are the 4 clusters that you have got. This is with the Batchelor and Wilkins algorithm. So this is the final answer. Let us now move on to the next question. The next question is, find the clusters using the graph based algorithm for the following set of vectors with a threshold of 2.5 Euclidean distance. The points are again the same. So now you have to use the graph based algorithm to do the clustering. So for using graph based algorithm, the first step that you have to do is you have to obtain the similarity matrix or adjacency matrix. There you will have a edge between 2 points if the distance between Euclidean distance between the 2 points is less than the threshold. Then you will have a edge between those 2 points. Otherwise you will not have the edge. So first you will again compute the distance matrix between all the pair of points, and then you will threshold those distances at here 2.5, and whatever distances are less than 2.5 you will have the corresponding edges in your graph. Now you will have to choose that point which is having the maximum, that the row corresponding to which is having the maximum number of ones, and the points which are connected to this particular point, all of these you will take in the same cluster, and you will check if any other point is connected to any of these points, you will also include those. Now you have completed one cluster formation, you will go to the next remaining points and do it in a similar manner. So the first step for this problem also is again obtaining the distance matrix. The distance matrix is the same that we have already used in the last problem. So you can simply threshold that distance matrix at 2.5, and whenever you have a distance less than 2.5 you have an edge between those two pair of points. But yes, the distance between A and A will also be 0, and you will take that as connected, but there is no edge between that. So A and A distance is 0, which is less than 2.5. So you will put a 1 in the adjacency matrix or similarity matrix. Now distance of A and B is 1, that is also less than the threshold 2.5. So A and B will have the AB point will have the entry 1. Now for the remaining points, the distance with A are more than 2.5. So for all those cells you will have the value as 0. So all these will be zeros. Now for the point B, if you see, only the distance with point A is less than 1. For all other points the distance is greater than less than 2.5. For all other points it is greater than 2.5. So only A and B are connected. B and B is always less than is always 0 anyway. Remaining all entries are zeros. Now for the point C you will have to do similarly. So you can see with C, if you consider the distances of other points, D, E, F and G are having distances less than equal to 2.5. So all those entries will be 1, and the entries for A and B will be zeros. Okay. For D, A and B are again having distance more than 2.5, and remaining all points are having distances less than 2.5. So it will be Similarly, you will have to complete the entire matrix. So, this is the complete similarity matrix or adjacency matrix you have. Now, you will have to choose a row which has the maximum number of ones. So, you can see all the rows corresponding to C, D, E, F and G have 5 ones. So, let us take the first one of them, which is corresponding to C. Now, you can see in this row, if you check the 1 entries, you will see that C is connected to D, E, F and G. So, all those will go in one cluster. So, in the first cluster, you will have C, D, E, F, G. Okay. Now, you will have to check if there are any more connections with any of the points of this cluster. So, you have checked with C, only D, E, F and G are connected. Now, you check with D. Go to the row corresponding to D. Here also you can see D is connected to C, E, F and G. So, those are already in the cluster. Now, go to the next point, which is E. This is also connected to C, D, F and G. These are also in the cluster, so no need to include anything. Similarly, for F and G, these are also connected to these points only, which are already included in the cluster. So, these are all the points that will be included in this cluster. Now, you have to remove all the rows and columns corresponding to these points. So, you will have to remove this part and this part. Then you are left with only A and B, and A and B are connected. So, the other cluster that we have, that will be A and B only. So, using this algorithm and setting the threshold at 2.5, you will get only 2 clusters. One is containing A and B, and the other cluster is containing C, D, E, F and G. So, you see, depending on the threshold, you can have more clusters also. If you put a threshold much lower, then you can get even more clusters. Okay. So, this is the current, this is how you use a graph based algorithm to do clustering. This is how you do the graph based clustering. Now, let us move on to the next problem. Problem 3. This, let's see what this problem says. Consider the graph shown below. Which of the following are the edges in the MST or minimal spanning tree of the given graph? So, we will have to form the minimal spanning tree of this particular graph. Now, to form the minimal spanning tree, that is basically you will have to remove some of the edges from this graph, so that there is no cycle formed within the graph. Also, the sum of the weights of the edges that you are including in the spanning tree, that should be the least possible. So, you will have to obtain the minimal spanning tree. First, you will have to take all the edges, the weights of all the edges, and sort them in the ascending order. So, that first you have the edge with the minimum weight, then you have the next, and like that you are increasing. Now, you keep on adding the edges in this particular ascending order of the weights in your minimal spanning tree. And while adding this, you will have to ensure that if you encounter some edge which if you include in the spanning tree it will form a cycle, then you should ignore that edge. Like that you will have to proceed unless you have included all the nodes in your minimal spanning tree. Once you have got all the nodes in your minimal spanning tree, then you are done. That will be your minimal spanning tree without any cycles and the sum of all the weights being the minimum possible. So here in this graph, if you see, if you consider all the weights of all the edges, you see that the minimum weight is for F and G. That edge has the minimum weight of 4. So the first two nodes and the corresponding edge that you will have to add in the minimal spanning tree is F and G and the corresponding edge. So I am just drawing beside only. So first you will add F and G and the edge in between having the weight 4. Now next I'm having really bad network connection today. So we have added first the edge with the minimum weight. Now the next minimum weight is present is 8, which is in between A and E. So next we will have to add these two nodes and the corresponding edge in our minimal spanning tree. Once you have added that, the next minimum weight present is 10, which is in between E and F. So next we will add that. Now among the remaining, the next minimum weight is 11, which is between A and B. So again we will add that. After 11 there is 15, which is between B and E. But you see, if you add this edge between B and E, then you will form a cycle in your minimal spanning tree, and spanning tree should not have any cycle. So we cannot include the edge between B and E. We have to move on to the next one, which is between D and F, and its weight is 18. So this we will add. Next is 19, which is between B and C. B and C, this is 19. Now you can see that you have already included all the nodes in this minimal spanning tree. Now if you try to add any more of the edges, whatever be it the one with the minimal weight among the remaining edges or whatever, you will form some kind of cycle in the graph. So you will have to stop here, and this will be your minimal spanning tree. So you have already included all the nodes, and if you take the sum of the edges, that's the minimum possible without forming any cycle. This is how you produce your minimal spanning tree given any graph. The next problem that we have is on minimal spanning tree based clustering. So let us see that. Sorry for the delay, I was trying to get the screen up. Okay, so the next question is obtain the clusters using MST clustering for the following vectors. Assume threshold distance for clustering is 3 and you have given 6 points. So the first step in this particular problem is also, first you will have to have the distance matrix, then based on the distance or weight matrix, you can see, the weights are basically the weights of the edges, which you will compute as the Euclidean distances between the points. So once you have the weights, you will have to form the minimal spanning tree from that, and you will have to cluster the Euclidean distances at 3 to obtain you have to threshold the Euclidean distances at 3 to obtain the clusters. So the first step will be to compute the weight matrix between these points. So let's do that first. Sorry. So the distance matrix So the distance between A and A, Euclidean distance, will be 0. A and B, the Euclidean distance will be 1. A and C, the distance will be 2.2. A and D is 5. A and E is 8.1, and A and F is 9.4. Similarly, you will have to complete this entire matrix. So let me first write down the entire weight matrix. So this is your complete weight matrix. Now you will have to form the minimal spanning tree based on adding, similarly as we did in the last problem. You will have to keep on adding the edges having the minimum possible weights. So if you check in this matrix, the minimum weight that you have is between A and B. So the first set of nodes that you will add in the minimal spanning tree are A and B, and the distance between them is 1. So let's say you add A and B and the distance is 1. Now you can take any of these nodes as your root node. I forgot to mention that in the previous problem also. The first edge that you add to the tree, you can take any of the nodes of that edge as your root node. So here let's say we take A as our root node and B is the child of that. Now once you have added A and B, the next minimum weight present in this set of points is 1.4, which is between E and F. 1.4, which is between E and F. So next you will have to add E and F. Let's say we add E and F with the weight 1.4 in between them. Now the next minimum weight present is 2, which is between B and C. So next you already have B, next you will have to add the node C, and the distance weight is 2 for that edge. Once you have that, the next is A and C. The distance weight is 2.2, but you see if you add A and C, that will form a cycle in this graph, so you cannot add that particular edge. Next you have 2.8, which is between C and D, so you can add that 2.8. Then after 2.8 you have 4, which is between D and E. So you see already you have included all the nodes in the graph A, B, C, D, E and F. So if you try to add any more edges in the tree, then you will form cycles. So you have already reached your minimal spanning tree. Now the next step for doing the clustering is to threshold the distance to at 3. So the edges that you have, the edges for which the weights are greater than 3, you will have to remove those edges from the graph. So only you can see in this particular minimal spanning tree, the edge between D and E is having weight 4, which is more than our threshold 3. So we will simply remove that particular edge. So we'll just remove this edge between D and E. Now your tree gets divided into 2 sets of points, one set having A, B, C and D, and the another set having E and F. So that is the 2 clusters that you have got, A, B, C, D in one cluster and E and F in the other cluster. So this is how your minimal spanning tree based clustering algorithm works. So with the minimal spanning tree based clustering algorithm, you have got 2 clusters, A, B, C, D in one cluster, E, F in the other cluster. Now moving on to the last problem. The last one is on k-means clustering. So here it is given that cluster the following 8 points into 3 clusters, and you have been given 8 points here. take the initial cluster centers as A1, A4 and A7 and let the distance function between 2 points be given as, if the points are A and B, your distance will be the difference, absolute difference between the x coordinates plus the absolute difference between the y coordinates, and use the K-means algorithm to find the 3 cluster centers after the second iteration. Since we do not have much time, we will go for one iteration and you can similarly do for the second iteration. So, as the problem says, the first step, you have 8 points and first you will choose A1, A4 and A7 among these 8 points as your 3 cluster centers. So, you have C1, C2 and C3, let us say, as the 3 cluster centers. Those will be actually A1, A4 and A7. Now, you will have to compute the distance of all the points according to the given distance function from the 3 cluster centers. So, let us do that first. So, the distance between A and A is 0, the distance A1 and A1 is 0, the distance between A1 and A4 is distance between A1 and A4 is 5, A1 and A7 is 9. The distance in case of A2 with C1 is 5, then 6, 4. Similarly, according to the distance function given to you, you will have to compute all the distances for all the points from the 3 cluster centers. So, if we complete this table, then we will get now. Once you have computed the distance of all the points from the 3 cluster centers, for each point you will have to check or find out the minimum distance, and if you get the minimum distance is with, let us say, the first cluster center C1, then you will assign that point to cluster C1. So, if you see, for A1 the distance is 0 with cluster center C1. So, A1 will be assigned to cluster C1. A2, you can see the distance is minimum with C3, which is 4, the distance is 4. So, it will be assigned to C3. Similarly, A3 will be assigned to C2, A4 to C2, A5 to also C2, A6 again C2, A7 to C3, A8 to again C2. So, like that you have assigned all the points in any of the 3 clusters, in one of the 3 clusters you have assigned based on the minimum distance criteria. Now, once you have made these assignments, then you will have to again compute the cluster centers. For this cluster center computation, you will have to take the mean or the average of all the points allotted to that particular cluster as that cluster's center. So, you can see, to C1 only one point is assigned, A1. So, the average will also be the same as the coordinates of A1. So, C1 will be, the cluster center for cluster 1 will be 210. Now for C2, you can see A3, A4, A5, A6, A8. All of these are assigned to the cluster C2. So you will have to take the average of all these points, and that will be the new cluster center C2. If you take the average of all these points, you will get 6, 6. So 6, 6 will be the new cluster center for C2. Similarly, for C3, you have A2 and A7. You will have to take the average of A2 and A7, and you will see that your cluster center will come up as 1.5, 3.5. So now these are the 3 new cluster centers, and the assignments to these particular cluster centers are already we have done. Now what you have to do is, again you will have to compute the distances of all the points from these 3 cluster centers. This will be the second iteration. So let's do that also for a more clear understanding. So now your C1, C2, C3 has changed. It has become 2, 10, 6, 6 and 1.5, 3.5. Again you will have to compute the distances of all the points A1 through A8 from these 3 cluster centers. Now again you will have to compute the distances of all these points from the 3 cluster centers. The distance again will be computed using the given distance function. So if you do that, you will get again you will have to take the minimum distance for each point and assign it to the corresponding cluster. So A1 will again be to C1, A2 will be assigned to C3, A3 to C2, A4 to C2, A5 to C2, A6 to C2, A7 to C3 and A8 to C1. Okay. So you see 2 points are assigned to C1, 2 are to C3 and remaining are to C2. Now again you will have to refine your cluster center estimates. So again you will have to take the average of all the points assigned to that particular cluster. So for C1 the points assigned are A1 and A8. If you take the average of these two, you will get 3, 9.5. That will be your updated cluster center for the first cluster. For C2, you will have to take the average of A3, A4, A5 and A6. If you do that, you will get 6.5, 5.25. That will be your new cluster center for cluster 2. And for cluster 3, the points assigned are A2 and A7. So again your cluster center for C3 will be 1.5, 3.5. So these will be the cluster centers after the second iteration, and these will be the corresponding cluster assignments. Like that you will have to keep on refining unless the convergence has been achieved. By convergence I mean that the assignments of the points to the clusters do not change in consecutive iteration. Then you can think or you can assume that the convergence has been achieved and this is the final assignment you will have. So, like this you will have to keep on doing for multiple iterations. So, this is all for today's session. I am really sorry for the network interruptions that we got today. If you have any question, you can ask at this point. Okay, so since there is no question, thank you everyone for joining.